Boom. Straight line relationship between two variables, and generally speaking, when we first introduced these, we give you the equation y equals mx plus b, which is what we were talking about yesterday. Y is the dependent variable. It changes in reaction to x. X is the thing that either you change or changes on its own that you don't control. Things like time. Very rarely do you control time, if ever. So x is your independent variable. Y is your dependent variable. M is the slope value. We said rise over run. Then you guys said y2 minus y1 over x2 minus x1. And then I inserted this little guy here to end the block. The idea that, this is where y2 minus y1 and x2 minus x1 comes from. It comes from this idea that the rise is a change in your y value, which is what that little triangle there means. And this is a change in your x value, which is what that little triangle means. It's the Greek letter delta. If you had me for pre-diploma math 9, you've heard that before. If you didn't, then did we do it in grade 10 science? I don't think it shows up anywhere else. So, we need B. Where's my arrow? What color do I want?
Purple.
Actually, I went for like bluey gray. Same color as this one down here. So B, what's the B value in that equation? What does it mean? Y equals mx plus b. B stands for?
Y-intercept.
The y-intercept. And just so we're clear, the y-intercept is where, I don't have a lot of space, the line hits y-axis. I'm going to draw a line up here because I want to make another note about the y-intercept. When you guys, this is generally speaking what you've done with these concepts up to this point. You either get given a graph and you get asked to analyze all these things, or they give you data and you have to draw the things. But often you're given the y-intercept. With what we're going to do, you cannot assume 0, 0 is the y-intercept. Even if it would make sense logically for that to be the case. I'll give you an example. So we're going to do a bunch of labs. You're going to have to graph most of them. One of the things that we're going to look at is next week, maybe the week after that. At some point in the next 2 weeks, you guys are going to get 2 cars, blue car and a red car. And you're going to put them on the ground, you're going to turn them on, and they're going to go. One of them will be faster than the other one. The slow one will move very, very slowly. And you're going to have to figure out how you're going to take the time. You're going to time them as they travel a set distance. The y-intercept for that scenario, cars at the starting line at the beginning of time, you turn it on and start timing and it goes. The y-intercept represents what? If you're graphing distance traveled versus time taken. The y value is distance. The t value is time. So at time 0, your y-intercept is the distance. So theoretically speaking, how much distance from the starting line should your truck have traveled at the beginning of time? It should have traveled 0. But what does that actually mean? Where is 0 distance? Because you're going to put this thing on the starting line. But if you don't place it perfectly on the starting line, if you place it a little back from the starting line, at time 0, your y-intercept isn't going to be 0, it's going to be negative. If you put the truck a little bit forward, okay, gentlemen, give them a, if you need writing utensils, I got pencils up there at the front by the printer. If you put the truck a little bit forward, now all of a sudden your y-intercept is going to be positive. It's not going to, either way it's going to be above 0 or below 0 unless you're exactly perfect. And I hope throughout the error stuff that we talked about 2 days ago, I hope you two impressions. One, that you're not perfect. And two, it's actually really good to recognize that you're not perfect, because the more you, especially in a physics lab, in a chemistry lab, the more you recognize your own imperfections, the bigger your error window is allowed to be. And if we say, oh, like I don't really think I took this measurement very well, all of a sudden your error is going to be bigger, which means you have more of a wiggle room to reasonably fit results in. And so because what we're going to be doing is graphing so many, and that'll make sense as we go through stuff, but because we're graphing things that you're actually going to be physically measuring, you cannot assume that 0, 0 is the y-intercept. You're going to graph your data, and then your lines are going to tell you what 0 is. So here is, I want you to draw one. I want you to go up. Where do I want you to go? 1, 2, 3. Okay. I want you to go up. Let's go 5 dots. I want you to put it there. 1, 2. Actually, you went up 1, 2, 3, 4. That's what I want you to do. Go up 4, put a dot. On the top of the page, I want you to go down. Down 1, 2, 3, 4 from the top right corner. And I want you to place another dot. I want you to take your straight edge. I want you to connect those 2 dots. Oh yeah, we're gonna do a lot of straight lines. You're right, there is no straight lines in Pre-Calc 12. They're all curved. And sometimes they only curve. They're constantly curving. Yep. Yeah. Okay, so we actually have curved rulers that I'm gonna teach you how to use too. So here's your line. We should all have the same line if you followed my instructions. You went up 1, 2, 3, 4 on the far left. You went down 1, 2, 3, 4 on the far right. I want the slope and I want the equation of that line we just drew. What is the equation of that line? On your mark, get set, go. All of you, figure this up. Spend a second. What is the equation of that line? You're going to have to find the slope. You're going to have to find the y-intercept. Put all of that in there. Find me the equation of that line. Sorry, what are you saying?
We don't know.
No, there's only one y-intercept. The y-axis only exists in one spot. The y-axis exists right here. The x-axis exists along the bottom. Doesn't matter if it ends. We're not piecewising things. It might not end. You know what? Here, fine. Here's an arrow. Boom. Means it goes on forever in either direction. Does it? If that's going to mess you up, we'll put arrows on the end. It goes on forever. Find me the equation of that line.
Why are you making it a triangle?
That's a great question. Why am I making it a triangle? Find me the equation of the line, math student.
No, math student. I want to do something. I'm not a math student. I just want to do biology.
Well, yes, Levin. Sorry, what? I don't know yet. I'm not done yet. I'm doing it right now. I'm gonna divide them by 2. Divide them by 3. I'm gonna get 3/5. So I'm gonna get y x plus 4. Okay, I'm done. What do we got? Recall. To find the equation of a straight line, again, if you follow the instructions, we should all have the same equation. You're drawing the line between those 2 points. You need to find the slope. We define m and b. We're filling in y equals mx plus b. So to find m, you guys said yesterday, m is rise over run. So how far does the thing go up divided by how far does the thing move left and right? It's going up to the right, so the slope should be positive. And that'll be your m value, and then plus b will be your, well, whatever the y-intercept is going to be your plus b. So what do you get for, what do we got? Give me some, let's go, you know what, I can erase this. Make it, looks like it's stuck.
You can say it.
11, what was your answer?
1.5x plus 4.
You got 1.5x plus 4.
Here's all the fish.
I erased the fish. It's true. Next time, put the fish in this box. Okay, so 11 got y equals 1.5x plus 4.
Yeah, no, yeah, that's right.
Okay.
Good job, you wrote it down in a different.
How did you write it? What do you mean?
Like f, and then x, but then squares. Yeah, that is.
Oh, you can write. We do that too. It's function notation.
I hate
Except in physics, I don't want to use function notation because we're gonna relate different variables together. We're not gonna call things functions of. We're gonna talk about
No, 0.5.
0.5x.
I hate function notation.
Function notation is wonderful. Okay, who else? Give me something else. Get something. Anyone get something different than 11 got?
1 x, which is x plus 4.
You got y equals x plus 4.
Yeah.
That's your answer.
Yes.
Calculate the slope. You got a slope of 1.
No.
Those are very different lines. We all drew the same one. Careful. Okay, anybody else? I think my answer is even different than that yet. Yeah, I got something different. Who else? Have we figured it out? Are we just scared that
I'm scared now.
we forget how to find the slope?
I'm
We
scared.
forget. Okay. Then let's do it. Oh, you got it. What do you got here? What's your rise?
4.
Your run.
Grade 11 isn't allowing G through O.
G through O. Get your stuff. Get out of here. No, well, no. Take your slip and eat that in here. Get your picture taken.
Go forever.
Okay, there you go.
OBQR. Okay, so again, this is what you guys are starting with. Y equals mx plus b. M, you guys said yesterday, was rise over run. So on that line that I had you guys draw, what's the rise, what's the run? And it depends on how you pick the points that you're going to talk about rising and running between. Rise is a vertical change. Run is a horizontal change. Levin got y equals 0.5x plus 4. I did not. My answer is slightly different, but not a lot different. Sienna,
Did something.
would you like to make a change on this? Do you have a rise over a run?
It's
Come on.
No, I'm good.
Do you have a rise? No, answer my question. Do you have a rise over a run?
No.
Okay, well then you're not done. Finish. You have an mx plus 4.
it's
Fill in the m. Find me a rise and run.
It's not 4.
Saf, what do you got? You look like a man who has an answer. You don't have an answer. Okay. What is going on with this desk comp? Why is it all askew?
There's no space.
Yeah, there's no split. How does that keep happening? Seneca and Harnur, can I get you guys, Seneca, can I get you to slide back so that your desk is in line with, yeah, and then we'll slide that desk next to you over. Yeah, and then Harnur, you can just, yeah, whatever's comfortable for you. Yeah, 11.
It's 8 divided by 15.
You got 8 over 15?
Yeah, 8 over 15. It's like 16 over there.
So you got y equals 8 over 15 x plus 4.
Yeah.
Okay. I got something different yet.
So it's over 3.
I got something. I got y equals 0.6x.
You got y equals 0.6x plus 4. Okay.
I got 9 over
9 over 10. Okay. So y equals 0.9x plus 4. Okay. Anybody else? Now you got something, Seth?
1 over 2.
Okay, so if you're back to 0.5, y equals a half x plus 4. In physics, in math, you're probably used to your math. You're saying, yeah, fractions, rise over run there makes sense. I like, in physics, working in decimals actually makes it, I think, make more sense. Especially when we start talking about what these things mean. Yeah, you bet. So I chose the points that I chose for a reason, obviously. There's always a reason. Take a look at the line. So here's my slope calculation. I went, the only points that I said I know for sure, beginning and end. I know exactly where those points are because I told you where to put those points. And the rise is 18, the run is 30. 18 over 30 is 9/15, which is 3/5. So if you want the right answer, unless I screwed up my fractions because my head's a little foggy this morning, the equation should be y equals 3/5 x plus 4 or y equals 0.6 x plus 4. But if you look at what's going on here, and again, this is wildly relevant to what we're going to be doing with the data that you get. I'm willing to, anyone who didn't get 0.6, if you got 0.5 or if you got 0.9, 8/15. What's 8/15? 8 over 15 is, oh, nope, don't want that. 0.53 repeating. Just because the answer is 0.6 doesn't mean that those aren't valid answers, because what I'm willing to bet is you looked along here and you said, okay, you went along and you found a point you felt went through. Sorry?
I know I just.
No, don't make any changes. Don't make any changes. You're good. I keep quoting the words right answer because, again, this is physics, not math class. Just because you got something different doesn't mean that anything you did was wrong. What you did, I mean, I'm willing to bet what happened was you went along and you looked along the lines, you said that line looks like it goes through.
No. I just went. I did the graph wrong. So.
Oh, you did the graph differently. Oh, okay. Well, that, yeah.
16, not 18.
You're right. Okay, so you miscounted. Okay. But for some of you, I'm willing to bet you went through and you were counting points. You're like, okay, that looks like it might be a good point. That might be a good point. And so got a slightly askew slope, and that's okay. What I care about is the procedure. So let's look at something that you're probably going to find more likely occurring in this course. Here's a graph. This is a graph. We have voltage on this side. We've got current down here at the bottom. And we want to find the slope of this. So what's interesting about those dots? Take a look at the graph. It is technically speaking, it's non-linear. But what's the relationship between voltage and current supposed to be? Something you would have looked at in grade, for those of you in grade 12, you're at a disadvantage. What in grade 9, you would have looked at the relationship between voltage and current. Does anyone remember what it is? V equals. We'll put it up at the top here. No, V does not equal MC squared. V equals. Nope.
C over it.
No, C is not part of it. A is also not part of it.
Oh.
But you might be confusing the units for something. Voltage is equal to. What's the I? It's not I over R.
R over
I times R. V equals I times R. And if we're graphing voltage and current, we can draw the connection between V equals I times R and Y equals MX plus B. Your Y variable in this case isn't a Y variable, it's voltage. Your I is the independent variable, the thing you're changing. You're changing the current and you want to know what the voltage says. So the I is actually your independent variable, which means the data or the physical concept here should be linear because it lines up. We know that voltage is equal to the current times the resistance, something that your science teacher would have told you in grade 9 and that we all just kind of accept and we know to be true. So then the slope of the data should be what?
Grade 11 students with last names P through Z, please bring your photo card to the jungle gym. Grade 11 students with last names P through Z.
Just go to the gym and tell them you don't have a slip and they'll tell you where to go.
Cool.
You'll be fine.
Okay.
Yeah, my fuck 18 just wasn't here.
Yeah, so that's fine. So like, look at this. If V is the dependent variable and X or the I is the independent variable, then the thing that multiplies the independent variable should be the slope, right? Like, are you following what I'm saying here? Kind of, sort of. So then because this relationship mirrors the equation that we threw down way back in either end of grade 9 or beginning of grade 10, the data should be linear, but as Andrew pointed out, it's not. So why, even if we know that it should be, why isn't it? What's the problem?
Error.
Error. Error in what?
Us.
Error in you, perhaps, or error in the device that you're using to measure the thing. What are we finding here? If this is linear and we do calculate the slope, slope is equal to R. R stands for the resistance. Now, a resistor is a physical object. For those of you who have never played with electronics before, it is a literal cylinder that gets shoved into a circuit board in some cases, it's a literal cylinder that gets plugged into a circuit board that exists to impede the flow of electrons. Someone made that resistor somewhere. Just because they made that resistor somewhere and they told you, yes, the value on this resistor is whatever we're going to calculate, 2, does that mean the resistor is going to be 2 its entire life? Not necessarily. It might be 2 when it's brand new out of the box, but what happens when it's been sitting in an electronic device for a while? Heating up, cooling down, heating up, cooling down. Maybe the resistance has changed. So that when you get to it, and now it's your turn to measure this resistor, maybe it's not a perfect resistor anymore. And so now all of a sudden what we've got here is error. There is error in this data. There's error here. Error in you. Error in your measuring device. Measuring device. Error in the object you're measuring. And so even if we know that the concept is related linearly, voltage, current, and resistance are related linearly, the data seems to suggest they're not. But we have to treat it like it is. And so even though as Andrew said, the thing's nonlinear, we know the relationship should be, so we're going to treat it like it is. So what kind of line have we just drawn here? Does anyone know the name of that line that we've drawn? We've used a straight line to approximate non-straight data. Does anyone know what we would call a line that does that? Okay, I will tell you. When you use a straight line to model data that isn't straight, this is called a line of best fit. It's the line that says, I know it should be, but it's not, so we're going to draw this line anyway. And so for this particular example, with the data that I plugged in here, the computer generated this line of best fit. You guys are going to generate lines of best fit for me as well, except you're going to start doing it by hand. And so you're all going to use the same data, And you might get slightly different equations because what you see as the line of best fit might be slightly different than the person beside you seeing the line of best fit, especially since most of you have never done this before. So what does it mean for it to be the line of best fit? Honestly, your lines are probably going to be lines of pretty good fit, and at this stage, that's great. Andrew.
So to find like the bests from our good fits, are we gonna take everybody's answer and find the median of it?
No. There is a proper way to find line of best fit using regression models, and we're not going to do that.
It's regression.
Don't worry about it.
Almanac.
That is beyond what we're going to do. There are ways that statisticians could by hand say, this is the line. But none of you are statisticians. We don't care about the statisticians in this class. And so we're going to ignore the statisticians. Okay, so the other thing I want you to do now is extend this line, put your ruler on the line that was given to you here. And I want you to extend it back to the y-axis. What's the y-intercept?
Almost zero.
Sorry?
Almost zero.
Almost zero. So not zero. What should it be practically? Like if we look at the relationship between voltage, current, and resistance, something you did back in grade 9, if there is no current, how much voltage should there be? Zero. No current flowing, no voltage. Makes sense. But according to your line of best fit, no current still means some voltage, and that's weird conceptually. But let's go ahead and figure out what the equation is anyway. So we've got our line of best fit. What we're going to do now is we're going to go ahead and we're going to make the equation. So we're going to start with y equals mx plus b. Don't rush ahead. I want you to model this. I want to model this together. Follow what I'm doing. So we're going to start. We know this thing should be linear. The data looks like it should be linear. Even though it's obviously not, it looks like it should be. So y equals mx plus b. The y is voltage. So the first thing I'm going to do is I'm going to replace y with the word voltage. The voltage that we're measuring is going to be equal to some value, which we're going to leave blank, leave some space there, times the current, our x value, plus, and then leave that little bit empty. We're going to figure out what this is going to be. So now I've given you scale on the graph. We've got 1, 2, 3, 4, 5 lines is 0.2. And on the bottom here, we've got 1, 2, 3, 4, 5 lines is 0.1. So what we're going to go ahead and do now is we're going to go ahead and we're going to find the y-intercept, and we're going to go ahead and find the slope. When you have data that looks linear that isn't, to find the slope, you do not use data points. I'll make a note of this here at the bottom. To find slope, do, and then capital letters, not use data points. We plot the data points to give us our line of best fit, and then once we have the line of best fit, we ignore the data points. We want to use the line of best fit to calculate the relationship. So to find the slope on this thing, I just went the beginning and the end because I knew exactly what those points were. For something like this, we're not going to go beginning to end because I don't know what those points are. We want to find 2 points on this line that we feel, or that you feel, goes through your grid exactly, so we know what those values are for sure. Find a couple points on that thing, on this line, that you feel go through the grid perfectly at a corner on the square. I've got a couple here that I could use, but I want you to do that. Find 2 points that you feel goes through the grid exactly. I'm going to pause this, and I'm going to pick some points as well.
I have these two, but I can't figure out.
I'm going to go with that point there. So you're just following along the line until you find a point that you feel exactly goes through the corner of the grid. Where's my other one? Really? That one there? Which one's that one? I'm going to use that one. And then,
Yeah.
as Sienna asked before, why am I drawing a triangle? On the grid, I want you to draw the triangle that lies between the points that you used, and I want you to label the coordinates of those points on the grid as well. So I've paused the screen so you can't see what I'm doing. I want you to try and do this without copying mine exactly. Find 2 points where you feel the line goes through the grid and then label the coordinates of those points. So I'm going to finish mine. 0.32, 0.34, 0.36. And remember, the coordinates always go x, comma, y. And this guy down here is yeah. So 0.24, 0.28. I do also want to draw attention to something else Sienna muttered, which some of you might have not have heard, and that's totally fine. She muttered it. But Sienna, I don't want to call you out, but I'm going to call you out. I very much appreciate how much of most people's inner dialogue is your outer dialogue. You say everything that you're thinking, which really helps. Because I'm willing to bet the vast majority of this, well, she's now your own grad, so don't even worry about it. These are 11th things. You're graduating. You've better than that. Don't tell them I said. I don't believe that to be true. We're getting rid of her. They'll last to all of us. But you guys better love. One of the things that Sienna muttered while she was doing this is, I don't know what these tick marks actually are. Right? Yeah. So let's take a look at what they are. Take a look at what's happening.
At this time, if grade 12 students with last names A through F could please bring your photo card to the jungle gym. Grade 12
Perfect.
students last
So take a look at what we've got here. The scale that's on the graph, and I'm definitely in your way, I'm sorry, goes up 1, 2, 3, 4, 5 lines and takes us to 0.2. So what's the value of one of these tick marks? What is 0.2 divided by 5? What is 20 divided by 5? So what is 0.20 divided by 5? 0.04. So every single one of these lines is 0.04. So 0.04, 0.08, 0.12, 0.16, 0.20, 0.24, 0.28, 0.32, 0.36, 0.4. So that's what you're going up by as you figure that out. If you're ever stuck to figure out what these things are, figure out how many lines there are between your bottom value and your first value, and divide by how many lines it takes you to get there. 0.2 divided by 5 is 0.04. So maybe that'll help you go figure out what your points are. I'm hoping at this stage that all of you have them labeled. You should have a graph that looks like this. You did the other direction. Okay, so you put your triangle on the top side. Whatever, I don't care, doesn't matter. That's fine. These are the points I chose. You did not have to choose these points. You might say, well, he's the physics teacher. He's going to be better at finding these things than me. That might be true, but only because I have... How long have I been teaching? 12 years. Plus the 4-year physics degree. 16 years. I've been doing this for literally 20 years. From the first time a science teacher was like, line's the best fit, here we go, to today is 20 years. So yeah, my intuition's going to be honed. But that doesn't mean that your intuition isn't valid. Pick your points. These are my points. 0.36, comma 0.8 and 0.12, 0.12, comma 0.28. These are the points. Now I'm going to use those to go ahead and find my rise over run. And believe it or not, these are not the same points I picked last semester. These are the points that I picked last semester.
Oh.
This point happened to be the same. Actually, this isn't from last semester. This is 2 semesters ago, a year ago. This point happened to be the same, but last time I picked this one instead. 0.14 and 0.32. This time I picked 0.12 and 0.28. Whatever. I purposely did not look back. Just, your intuition changes. Whatever. So now I'm going to go ahead and I'm going to find the slope. For all these calculations, when you guys are doing these for labs, I want the calculations done right on the grid. Everything should be done on the graph. So here we go. Rise over run is going to equal y2 minus y1 over x2 minus x1. And my values are, I'm always going to pick the higher point minus the lower point. That's just what I'm going to do. So I'm going to have 0.8 minus 0.28 over, what are my x values? 0.36 minus 0.12. And so my slope, assuming I did all that right, is going to be 0.8 minus 0.28. Oops, brackets are important. 0.8 minus 0.28 over 0.36 minus 0.12. Close bracket. Boom. And I want the decimal approximation. So I got 13 over 6 as my slope as a fraction. That's what my calculator gave me. But I'm getting if I change that into a decimal, I'm getting 2.16 repeating, which I'm going to round to 2.17. And a year ago, I got 2.18. So close. Very close. 1/100th out. But again, they're different, and that's okay. Give me some values you got for slope given the points that you chose. You should all be close to 2.17. But you might be above, you might be below. What do we got? Someone brave enough to share a value. You got 2.2. Does 2.17 round to 2.2? Yeah, you're great. You're 3/100ths different than mine. I think in the grand scheme of things, that's pretty good. So we have 2.2. I got 2.17. The rest of you guys, what kind of values are we talking about here? Andrea, what'd you get? 2.2 as well, or 2.22?
2.22.
Okay. 2.2 infinitely repeating. Okay.
I got 2.12.
0.12? Then you made a mistake. You should be at least mistakes from me. It should start with a 2. You're going to be close to what I got. Gyro, Dario, we got values. Gersira, you got a value? You have a slope value for me? You still doing it? Okay. Vikram, you got a slope value for me? Okay. I want all of you to do this. Find it yours. You should all have a value. Unless you're getting your picture taken and don't know what's going on, and I'll get you go get you caught up. Oh, yeah, something got
Picture taking crazy.
Okay. Okay. So which one?
And by the time I get back, I don't want that. That will-
Oh, rise over run, or you advocate. So in English, that's what we call it, the
Only-
change in the vertical and the change in the horizontal. It's all rise and run. No, I don't not work ahead. I do not want you working ahead. I want you working because you have been not taking any of the notes that we've taken.
You must-
Concepts I want you to do. Stop it, I do.
What do you think?
But it's not rise, it's going down.
What I'm asking you to do. What do we got? Happy if you're not gonna do the things that we do want to do the lesson, don't ask me for help, you don't get it.
I got the exact same.
Then if we help also not do this cool too.
So it's just your 1.4.
Well,
Zero.
and what we want to do is suspend it. I mean, if you choose not to fill the notes, he's not gonna get suspended. You still haven't done the things I want you to do. I said I want to.
You're putting the X and Y square.
Trying to. Points that are you going to show me the work. What have I done on the work plan? All the things that I'm asking you to do.
That sounds.
Grade 12 students with last names G through O, please bring your photo card.
Okay. And I have another trend here. You are a.
Well, we're not gonna be able to get it for like,
This is, so this line
for
here.
last. We're gonna be last.
All line of best fit.
Yeah,
You can
because they're
see
still
that.
grade one.
You pointed out what you were on. That these points aren't actually a straight line. When I draw a straight line through, like it's stuff above it, so. But. Let's zoom out a little bit here. Yeah, well, you can get it. If you're G through O, or. Yeah. No. So for those of you who are getting your picture taken, there's a bunch of stuff that you're missing there. I'll say it all again. Some of the song and dance, I'll give it to you again. So, you learned in grade 9, those of you who are getting your picture taken, that the relationship between voltage and current is V equals I times R. You take current, you multiply by the resistance, you find the voltage, and that's just the way it is, and there's never been any dispute. This is a graph between voltage and current, and voltage and current we know is supposed to be linear. So why are the points not exactly a straight line? If we had the discussion while you guys were going to get your picture taken. And the answer to that is because this is measured data, there's error there. There's error in U. Sometimes like you'll have a digital, if it's a digital meter that you're measuring on, there's the awful part where because there's small fluctuations in current, always, it might be right on the line where the meter is flipping back and forth. And so then at that point, if the meter's flipping back and forth, you have to make a choice. What value are you going to take? Because the meter tells you it could be 1 of 2. You decide what you're going to use. If you're using an analog meter, you're looking at the stick move. You have to decide what that value is. If you're looking at it slightly askew, if you're not bang on, headache that day, whatever, there's going to be error in how the measurement gets taken. There's error in the measuring device because some putts somewhere in the world in a factory out there put the device together. I mean, they're probably going to be pretty good because they'll get calibrated, but I mean, are they going to be perfect? Are they all going to be exactly the same? Probably not. They're going to be close. But there's going to be error perhaps in the device. And then to figure out what as you're measuring this thing, what you're measuring is the voltage that's present as the current flows through. Well, what is it? It's a resistor. V equals I times R is analogous to Y equals MX plus V. V is Y, I is your independent variable, is your X value. So what should the slope of this line be? Well, it should be resistance, the thing that multiplies with your independent variable. But that's the problem here, is that the data is all kind of askew. And so we get a slope that isn't constant, but should the resistance be constant? You've probably never done this before. Maybe you did, depending on who you had for Science 9. Anyone who had a need for Science 9, we actually went into the lab and did this. But you measured resistors to find out what their resistance was. You did the flips, like you set the current, and here we go. But as you change, so a resistor is a physical object. It could be a light bulb, it could be a physical resistor that gets plugged into a circuit board and it exists to reduce current. Over the lifespan of that resistor, even though that resistor was made, stated with a stated resistance, as the thing gets heated up, cools down, heated up, cools down, heated up, cools down, and you all know electronics eventually fail. That process of heating and cooling is going to change the resistor. And so maybe you got a resistor that's slightly different. Maybe you got a resistor that's old. It's not brand new out of the package. So for whatever reason, that shows up. With a current value of 0.3 amps, you got a voltage value that's lower than it should have been. Why? I don't know. But that's what you got, and so that's what we're going to use. Don't go by what you think it should be. Go by what, bless you, what actual data you got. And so you're going to often, even though the relationship, most of the relationships that we look at are going to be linear in this class, you're going to get data that for whatever reason isn't. And that's okay. So because we know that the relationship should be linear, and those plots, like if you stood far enough away, and I threw those dots up on the screen, you'd be like, yeah, that looks like a straight line to me. It's only when we get kind of closer and I zoom in, you're like, oh, okay, yeah, there's some wiggles there. So what we can say is we know that the data looks like it should be linear, and the relationship that we were given in grade 9, it's linear. Y equals mx plus b, b equals I times r. So we're going to use a straight line to model this. And so this is where you guys haven't drawn that line. It was given to you on the computer. That line is called a line of best fit. It's the best approximation we can give for a concept that we know to be straight, to be linear, even though the data isn't. There are ways to make a perfect line of best fit. As you go on, if you choose to study statistics, you'll look at regression models and you'll be like, okay, I can regress this thing to give me the line. And a computer will do this. If you took that data that I plotted there and you shoved it into Excel, or you shoved it into Google Sheets, or you shoved it into a program called Desmos that I'm going to show you, all of those different pieces of software will use the same regression model to give you the line. But y'all are going to be doing it by hand a whole bunch. And so your version of the line is going to be different, and it's going to get honed. How you draw that line of best fit, again, I've been doing it for 20 years. My intuition for what I think a line of best fit should look like has been honed over years and years of practice. A 4-year physics degree, teaching this course for the last 12 years, 13 years, something like that, right? Like, you practice, it gets honed. I don't expect you guys to get the same line of best fit that I get, which is why for this first one, I gave you what I've given you. But you guys are going to do an activity. We might start it today, where we do something similar, and you're going to graph some stuff, and you're going to figure out what the relationship should be. And once you figure out what the relationship is, you should all know the value you should be getting, and I'm willing to bet you're not going to get it, and that's fine. We're going to talk about error there then too. So that is where you walked into as we were finding this. So then what I had everybody do is I had us highlight the line there to extend it back to here, which we haven't talked about yet. And then I said, I froze the screen, and I said, okay, I want you to find the slope. Pick 2 points. So when I froze it, so these guys didn't see me picking my 2 points. I picked my 2 points, and again, I want you to do this on the graph. When you're doing labs for me, it needs to be all, like, you hand in the graph, it should all be there. So I picked the points 0.36, comma 0.8, and the point 0.12, comma 0.28. Violet got something slightly different. Someone said, Andrew, you got something slightly different. So Andrew's slope value was 2.22. Violet's was 2.2 exactly, and mine was 2.16 repeating, which I rounded to 2.17. But if you look at what we're out by Violet, her answer is different from my value by 3/100ths. Pretty good. In the grand scheme of voltage, what's 3/100ths of a volt? Minuscule, right? So up to that point is the discussion. Just what are you guys reading? Questions? About any of that? Okay, cool. Then we'll jump into the next piece here. I think were you guys back when I was starting to talk about the scale here? Yeah, you guys are back then. All right. Okay. So now what we have to do, we've got the slope. We know the relationship is y equals mx plus b. When there is no current, there should be no voltage, but if you draw the line of best fit, you're going to see this does not go through 0, 0. It goes through some other point, slightly up. So we need to figure out what these values, especially, and to figure out what these coordinates are, we actually need to figure out what the scale looks like. I gave you the larger scale. You have to use the scale. Do not count grid lines. But we go up here by what? 1, 2, 3, 4, 5 lines takes you to 0.2, which for the sake of mental math, I'm going to call 0.20 or 20. And we go up 1, 2, 3, 4, 5 lines. So 20 divided by 5 is 4. So 0.2 divided by 5 is going to be 0.04. So one of those lines.
Grade 12 students with last
See you later, Isabella.
P through Z, please bring your photo card to the tumble.
What we're going to get here is that these lines go up by 0.04. Oh, and Zora, you're 2? Okay. 1, 2, 3, 4 is going to be 0.04, 0.08, 0.12, 0.16, just to kind of demonstrate that. So let's zoom right the way in. So then, what is the y-intercept? If that's my y-intercept right there, if I'm going to ballpark that, what's my y-intercept? What's the value of that tick mark I just drew?
0.01005.
Well, okay, let's talk about that. Is it more than halfway or less than halfway, or is it halfway, Andrew?
I was looking actually at mine.
You're looking at yours, okay. Then, so looking at yours, is it more than halfway or less than halfway, or is it exactly halfway?
Less than halfway.
You think it's less than halfway?
Yours is roughly around exactly halfway.
Roughly around exactly halfway. If I draw another one, here's a blank one. Yeah, it might be below. I could see how someone could conceivably get below. Okay, so then with yours, you need to ballpark that. Mine looks either exactly halfway, or again, the thickness of my pen seems to imply that it's slightly above halfway. For the sake of this, let's call it halfway. What is halfway between 0 and 0.04?
0.02.
Thank you, Abdu. So that's going to be 0.02. So now I've got a y-intercept and I've got a slope. So I can go over here and I can say, okay, what I found the relationship to be between voltage and current is going to be that the voltage is going to be equal to 2.17 times the current plus 0.02. The language around this is that this, and again, you're not going to put 2.17 here. You're going to put whatever your value is for the slope that you found. Violet's equation would be voltage equals 2.2 times the current plus whatever her y-intercept is. Andrew, yours is going to be voltage is equal to 2.22 times your current plus 0. You said 0.15?
Yeah.
Sure. And so what this is going to represent is this is the equation of the line of best fit and this conceptually we know should be 0, but it's not. So what are we going to call that value? What is that value conceptually? The relationship between voltage and current is V equals my current times my resistance plus some error. That 0.02 represents the possible error in how I analyzed my data. Your error might be different. Andrew's yours was 0.15. Yours might be bigger than that. But this represents error or uncertainty is the other language we use around that. In the relationship that I found. So we're extending skills that you've done before. All of you by virtue, again, unless somehow you dodged taking Math 10. If any of you didn't take a Math 10, even A&W, like Apprenticeship Workplace, you were supposed to do slope stuff. If you somehow dodged taking a Math 10 class, this is going to be painful for you. And if that is you, please let me know. Questions, comments, concerns? Okay, if there are no questions, comments, concerns, I want you to flip the page. Real quick here, I've got 4 lines, A, B, C, and D. I would like you to find me the slope and the equation of those lines. On your mark, take giver. Give you a couple minutes to do that, and then we're going to talk about rules for wrapping things. I don't know. Maybe she burst into flames. I don't know. I think they just scanned it. I think you can throw it away now. Or is there instructions on the back for ordering? I never got my paper, so I don't know.
Use the QR code.
Hey. Oh, she's right there. She stopped at a vending machine.
I was wondering where you were. I had fun.
Okay, so I'm gonna go back. These guys are calculating slopes and stuff on the next page and equations for lines. I'm gonna go back and finish this. I'll rehab the discussion I just had with the rest of these guys. Two of you. We finished this up. We decided that, at least on mine, the y-intercept does not go through 0. It goes through. I figured it was halfway up the square. So half of 0.04 is 0.02. So when we plug the thing into the equation, y equals mx plus b, we know that voltage is supposed to be equal to resistance times current. This value represents the resistance of whatever object we're measuring,
Yeah.
plus 0.02. So it should be 0 because no current means no voltage, but it's not. So what this value represents is the error in certainty in the measure. In the whole process that I went through. And then I flipped the page and I want you guys to find slopes of lines and finish already. Fantastic. We'll go back and finish what you didn't finish. This guy. You give values here.
Here.
What's the ruler? Because that is not. I don't understand why the point of the block is the grad students dress up ridiculously for.
Yeah, that's your doing. This one.
No. You dress up fancy in January. Usually the grads
Like with wigs.
wear something stupid. Yeah, wigs and
That's what we wanted to do. They wanted. Yeah. What?
Why did you ask permission?
Yeah.
This is a last call for any staff or students who still need to have a photo.
Whatever you want to wear. What are they going to do? That would be taken. So they're going to say to the whole grad class, you can get your permission.
Yeah, if you wear a wig, they can't do it now because it's a safety thing.
Your dress code says you can wear hats. I mean, even there's other fun ways to do this.
I didn't know that was happening. I haven't.
One of the other things that I've seen is that they went to Value Village and they got like they got like 6 or 7 different button ups. So every grad is wearing one of those different button ups. They just all look exactly the same. But again, it only shows up in your student ID, so it doesn't matter. No, they buy your grad pic. Your graduate, they're not going to buy your school picture. They're going to buy your grad.
Every time. Every time. Last year I looked like a skinned chimpanzee. About a sunburn.
Okay, slopes and equations. We should be almost done. Slopes and equations. We should be almost done.
Oh, that way.
Yeah, man. So slope is a measurement of how much it goes up divided by how much it goes over. If it doesn't go up at all, slope is 0. So yeah, y equals 0 max plus 1. So that's, again, slope is a measurement of how much it goes up divided by how much it goes over. If it goes up and doesn't go over, slope is undefined. The language is I don't know what you say in Germany, but undefined. So we would call that.
Oh, this is going up. What is
Okay. So let's see if I can give you my values to these things. Yeah, man. Yeah, you're close. Go quick. Technically, it is 10-10, but I'm letting them go anyway. Slope is 0. Slope is undefined.
Or, oh, I got one other.
A is
Yeah.
negative.
I told you I'm blind. See those tiny lines? Is it bottom one? Is it
Okay, this one's dead.
Oh. Okay, we're good. I know.
I want to move to the tree. I want people the lines.
Trig lines don't go straight.
That's true.
They're curvy forever.
And then you got recalculus. You got a line with little bit something between. And you have a problem. What about the cubics, quintiles?
But they all curve exactly the same way. Well, like
You got
within
lines.
themselves, they curve. Yeah. Okay, so then the slope here is rise of 2, run of 1, 2, 3, 4, 5, 6. Equals negative 4 thirds x plus 3, and y equals 1/3 x. Don't pack up. Why are you packing up? Do not pack up. You are not done. Sienna, you don't get to pack up. I'm not even kidding. Get your stuff out. You're not done yet.
What about you?
I finished.
I did too.
No, you're still not done. Get your stuff out. Class isn't over yet.
Yeah, Violet.
I'm organizing.
Okay, you should be done. Here's what I got. Compare what you got with what I got. You need one of the things here that you need to remember is for a vertical line, the equation is defined by the x variable. So for a vertical line, you would reference that undefined, the slope is undefined for line B. So we would say that the equation for a vertical line is whatever the x value is, which is 6. So x is going to equal 6 is the definition, or is the equation rather, of that line. You've got, I gave it to you as fractions and as decimals. You might have something slightly different than I do. Depending on what points you chose, you should be close. Some of you may have chosen to extend the lines. That's what your rulers are for. You are welcome to extend the lines. So your answers for A and D do not need to be identical to mine. The slopes could be different for A and for D, and that is fine.
Okay, good.
But you still need to attempt them, Sienna.
I did.
It's underneath Kiana's foot. Her right foot. When you're done that, you may pack up. After you've checked your values with mine, Sienna.
Violet.
And tomorrow we will start playing with how I want you to graph in this course. And we're going to start doing some activities where you collect data and graph it, and it's going to be great.
So we do the big thing.
If you're going to be, yes, you're going to miss a lab activity tomorrow. One piece of homework for all y'all
Oh.
is you're going to be doing an activity in partners between you and a partner. Maybe if you want to discuss that today, that's great. You're not going to be working alone. I don't want you working on this alone. Between your partners, actually, you know what? No, I want each of you to do this. I want all of you, so that you'll have 2 objects, to bring a spherical or circular or cylindrical. Those are your 3 choices. You can either find something that is circular, cylindrical, or spherical. Please bring 1 object, each of you, to class that is either cylindrical, spherical, or a flat circle. Bring that to class tomorrow for our activity. Sorry? Sure. Is it spherical, or cylindrical, or circular? Then you're good. Bring me, if you're done with my rulers, those can go back up front. Bring me a cylinder, circle, or sphere tomorrow to class. After lunch. After lunch tomorrow. When the bell goes, you may go. Have a super duper day.
Now I have all my-
Excuse me,